All right, first one says the price P in dollars and the quantity X sold of a certain product obey this demand equation where P equals negative 0.5X minus 100. Okay? So again, we always want to understand what's given to us. This is the demand equation. So the price P is equal to this function where X represents the quantity sold. And then it says the revenue R is found by multiplying the quantity sold by the price. So let's start by coming up with that equation. What is the revenue equal to? All right, the quantity sold, which is given by X, multiplying the quantity sold by the price. So our revenue is equal to the amount that we sell times the price. That makes sense. Revenue is the total amount of money that comes in. So if I'm selling candy bars for $2 each, and I want to know how much money I brought in, then I'm going to take the amount that I sold. If I had a box of 100 candy bars and I sold all of them, then the number that I sold times the price, which was $2, the amount of money that I got in would be $200. Okay? So that's where that equation comes from. But I've told you that the price is really dictated by the quantity. And it follows this demand equation. So I can replace P with what it's equal to, which is negative 0.5x minus 100. And then if I distribute that x in, then what kind of equation am I dealing with? A quadratic equation. Everybody good so far? All right, then it says, for what quantity sold is the revenue greater than $9,375? So I want this revenue to be greater than $9,375. Okay? So I've taken the formula for the revenue, the statement for the revenue, and I've set it to be greater than $9,375. Everybody okay with how that's set up? What kind of inequality am I dealing with? Quadratic. How do I solve quadratic inequalities? I factor it, and then what am I going to do once factored? Test the intervals, right? You got to just ingrain that in your brain. Whenever I'm dealing with an inequality that's quadratic or greater, I have to test the intervals to solve it. Okay? Anytime we come across that, whether it's x squared, x cubed, x to the fourth, anything like that, I'm going to have to test the intervals. And to do so, I'm going to use factoring as my technique. So I think I want to get this all kind of to one side. So I just like my x squared to be positive. So I'm going to add over the 1/2 x squared. I'm going to add over the 100x. And then I have the 9375. I'm not real keen on factoring when I have a 0.5 in the front, but I could multiply everything by 10, and then I'm going to get rid of that decimal. So 0 times 10 is still 0. 10 times 0.5 is 5. 10 times 100 is 1,000. And 10 times 9375 is 93,750. Yeah, just get rid of this. As long as it goes to both sides. Now let's really think this through, okay? And again, this is maybe the transition that we're having to make from an Algebra 2 trig course to a pre-cal course, okay? Pre-cal is going to require us to actually use some common sense, some logical thinking, whereas in Algebra 2 trig, a lot of what we did was just solving problems over and over again, kind of doing things in the same manner over and over. Pre-cal now requires us to really kind of think through some problems and kind of make some leaps of faith and really kind of have an understanding of what's happening here, look at this quadratic inequality, or this quadratic expression. We know that it represents a function, and this function is going to be a parabola. The graph of it is going to be a parabola. Specifically, what kind of parabola, or what is that parabola doing? Opening upward. Okay. What does x represent? Quantity sold. Okay. What can you tell me about x? It's got to be positive, right? If I'm not going to sell a negative number of items. So the quantity sold is x. X has to be positive. Okay. So let's reason this through. X is positive. When I square a positive number, what do I get? I multiply by 5. Still positive, right? 1,000 times a positive number is positive. I take this positive number and I add it to this positive number. And then I add 93,750. Right. This entire side has to be positive, right? What am I asking you to tell me? When is this entire side less than 0? Is that going to happen? So without having to do any work, I know my answer is no solution. And I can reason that out. I didn't have to try factoring. I didn't have to try testing the intervals. What I need to do was understand what this problem is saying. This problem is saying, find where this quadratic function is less than 0. And what you're realizing is that quadratic function is never going to be less than 0. Okay? And even if it was, then it's for some value of x that's negative, and I'm not going to deal with that because my problem is asking for the quantity sold, where x is the quantity sold. It's not going to be a negative number. I would ignore that negative number anyway. Okay? So I know immediately there's no way where this is going to have a solution. Okay? There you got to think, right? And that's why I've said you've got to really understand what that problem is giving you and what that information represents. In the past, you've just been given a function, and you really, if it was a word problem, you didn't really care about everything else in the problem. You just dealt with that function and solved it like you would any other problem. Okay? But now, having that awareness of what is this problem really asking, what is it really saying, and kind of thinking through logically, then you realize, well, this is not possible. That doesn't make any sense at all. So my answer is no solution. And you could justify it if I asked you to. I said, justify your answer. You'd say, well, x can't be negative because it represents quantity sold. That right-hand side of that inequality has got to be positive. It's never going to be less than 0. Therefore, this has no solution. Okay? Right, okay? All right. Number 2. A rancher with 700 feet of fencing wants to enclose a rectangular area and then divide it into 4 pens with fencing parallel to one side of the rectangle. And we want to find the largest possible total area of the 4 pens. Okay? All right, picture. We want to take this rectangular area and then divide it into 4 pens. There's several ways we could do that, right? I mean, I could do this. There's 4 pens. Or we do this. There's 4 pens. Good, right. We had to read that whole problem. Parallel to one side of the rectangle. This won't work. Why not? Yes, this part of the fence is parallel to this side. This part of the fence is parallel to that side. That doesn't meet the specifications of the problem. Okay, that would have fencing parallel to 2 sides of the rectangle. Okay, this has fencing parallel to one side. Okay. It doesn't even really specify that the 4 pens have to be equal, right? I mean, I could have separated it that way. That would still work, right? Has anything changed about this problem then? No, it's still the same amount of fencing, right? So it really doesn't matter. Yeah, it really doesn't. Really, all that's telling us is that you got to split some of the 750 feet of fencing for that fencing down the middle. Okay? So ultimately, when I have a problem where here's my length and here's my width, and we've done a problem similar to this, we know that we're going to try and maximize the area of this, the total area of these 4 pins. Then the area is going to be given by length times width. But when we're trying to maximize, we need that to be quadratic because that's how we know the maximum occurs to the vertex. We're going to find the vertex of a quadratic. So what am I going to do with this 750?
5W plus 2L equals 50.
Good. 2L plus 5W. So yeah, 1, 2, 3, 4, 5 segments that we could label as W, and then the 2 lengths. And from this secondary equation, we're going to solve for one variable, plug that into the other, which we're gonna hope gives us a quadratic, and then from that quadratic, we can find the vertex, and we're golden from there. So, which variable do you want to solve for? W? All right. So to do that, I'm going to have to subtract over the 2L. Divide by 5. So what does W equal? $150 minus 2/5 L. So I've replaced W with 750 divided by 5 is 150 minus 2/5 L. That's what W is equal to. Then when I distribute in that L, I'm going to have negative 2/5 L squared plus 150 L. I wrote it in the standard form for quadratics. And it is a quadratic, so when I'm looking for that largest, that maximum, I'm going to find the vertex. And the vertex is found for a quadratic by doing negative b over 2a. And you're going to be careful when you put this into your calculator. You're going to do negative 150 divided by parentheses 2 times, if you want to do another parentheses, negative 2/5. And close both of those. Just make sure you put the entire denominator in parentheses. And what do you get for the length? Second? 187.5. Always have that awareness of what that's telling us. Okay? It's all, we always think of it, x equals negative b over 2a. In this case, we've replaced x with L. So L equals 187.5. What does that tell us? The length that's going to give us the maximum area. Okay? The question asked, find the largest possible total area. If it had said find the dimensions that would give us the biggest area, then our length would be 187.5, and we'd plug that in over here to figure out our width, and then we would know the 2 dimensions. But this told us to actually find the maximum area. So what am I going to do with that 187.5? Yeah, I can plug it in right here into my area formula for L, and then I'll be able to calculate that maximum area. Everybody good? All right, then number 3, I know it might have been a little bit difficult to see up here, but I asked you to find the equation for each of these piecewise functions. And of course, we know that all piecewise functions have the same format, where we do y equals or f of x equals, and then the brace, and then we're going to list the function and its domain for each piece that's in this piecewise function. So in part A, how many different functions do you think you have there? 2. What are they? Yeah. I'd say an absolute value and then a parabola that opens down. Okay? And this is where it might have been a little bit difficult to see it, but for this absolute value function, I think the easiest thing to do would be to remember that our general form for the absolute value is this. And HK should be pretty easy to find because what's HK? The vertex. So here's our vertex for this absolute value. It looks like it's at -4, -3. I think that's right. So I can replace H with -4 and K with -3. And then it looks like, yeah.
So do you specifically want to do the absolute value? Because like one of the problems I think with the homework, I actually did like 2 separate lines.
That's fine. So an absolute value could be 2 different lines, right? We could have had this piecewise function with 3 different pieces. A line here to this vertex, and a separate line here, and then the parabola. That's fine. That works. We got to figure out what A is, and maybe the best thing to do is just to find some other point that's on this graph, and then plug it in to see what A would need to be. Like for example, right here is the point -7, 0. So that means when I plug in -7 for x, I need to get 0 for y. So if I plug in -7 for x, -7 plus 4 is -3. The absolute value of -3 is 3. I need 3a minus 3 to equal a y coordinate of 0. A is 1. All right, so there's that part. But we got to identify its domain. And at what x coordinate does it look like this graph stops? -2, and we're going to keep the parts where x is less than or equal to -2. All right, then we'll do the same thing for the parabola. The equation for a parabola is a times x minus h squared plus k. Again, the h and the k should be very easy to find because that's just the vertex. And there is the vertex, which I believe is at 1,8, I think. If I give you one like this on the test tomorrow, it'll be much easier to read. And then to find A, we can plug a point in. Just kind of trust me a little bit that A is just a -1 in this particular problem. How do I know it's at least negative? Yeah, it opens down. Okay. Let's just kind of work under that assumption that that's what it is.
How did you find A's of 1 in the first one?
Because I saw that this point was on that absolute value. So I plugged -7 in for x. -7 plus 4 is -3. The absolute value of -3 is 3. So 3a minus this 3 had to equal to 1. Okay. And I would do the same thing with this parabola. It's just a little bit harder to kind of see any points that are on that graph, especially because the x-intercepts don't cross it exactly an integer. So just trust me on this one. But what would be its domain? X is greater than or equal to -2. So you can see this is a function that is a piecewise function that's continuous because where one ends, the other one picks up at that same x coordinate.
So would you have to say both of them are greater than or equal to 2? Or would you say
No, it could be one or the other. Yeah, you wouldn't have to say both. All right, for the next one, again, we'll set this up as our piecewise function is supposed to look. 2 pieces, do you agree with that? What's the first piece? Cubic, right? Cubic, and cubic has the form of a times x minus h cubed plus k. And what does hk give us in a cubic function? Not the vertex,
By where it's
a point of inflection, okay? And that point of inflection is that's kind of center point. And you'll talk more about points of inflection in calculus, but it looks like that's at, well, I think it's actually at -3. So -3, 0. So the x would be -3, and y would be 0. So that's your hk. And then, if we knew of another point, we could plug that in for x and y to find a. And like I said on the test tomorrow, if you have one like this, it'll be on a coordinate plane where you can see for sure what a point might be on that graph. But let's just trust that a is 1 for this one. Okay. What would be its domain here? X is less than -1. It's got to be less than what? Open circle, right? And then the next one is a linear function. That should be a little bit easier as long as we can find 2 points that are on that linear function. I know this right here is 2, 0, and 0, -5. I think that works. So with those 2 points, we can find the slope. So the change in y over the change in x. Looks like our slope is 5/2. And we know our y-intercept is -5. So the equation would be y equals 5/2 x minus 5. That's just that mx plus b form. We know our slope and our y-intercept. And what's its domain? Greater than or equal to -1. Good. All right. Everybody good? All right, so what I want to go over, we have about 50 minutes. We got homework from Tuesday night. We have homework from last night. We have quiz, and we have study guide. So we can go over any of that. Let me go ahead and give you back the quiz. What I'll do with this lesson quiz is I will put my key up on the website, so if you want to look at that later tonight, you can kind of compare yours against my answers and see where you may have messed up if you don't quite understand it, don't see it readily. But for now, are there any of those that you want to go over together, or anything that you're not real confident with? Number 3? Yeah, number 3 was kind of presented differently. We have y equals -3 times the cubic root of 5 minus x plus 2. Okay? And I know that's a cubic root problem. I know that I'm going to be graphing a cubic root. It's just not written in the way that it normally would be, because normally with a cubic root problem, we have x first, okay, inside the cubic root. So let's just rewrite this as y equals -3 times the cubic root of -x plus 5, and then plus 2. And so I just kind of rearranged it to put my x in the front inside that cubic root. But then something should come to mind here. What do you know about that negative in front of the x? we have to factor that out, okay, before we start doing any kind of transformations. Remember that x has to have, if there's something else added or subtracted to x, then whatever the coefficient is has to be outside parentheses. So what I'm going to do is I'm going to factor that negative out, which actually turns the x minus 5. And then now what we're able to do is figure out what our transformation rules are. Okay? But we have to force factor out whatever is attached to x inside the function. Okay? And you have to do that because, a lot of you ended up shifting 5 in the wrong direction. You actually had to shift 5 units to the right, not to the left. And it was probably because you didn't factor that negative out. Okay? So now, we move this up so I have some room. My parent function is the cubic root function. And what are some points that are on the cubic root function? -8, -2, -1, -1. Okay, so those are the points that are on the parent function. Then I'm going to come back to this function here, and I'm going to identify what all I'm going to do and in the order in which I'm going to do it. So starting inside the function, what am I going to do to the x coordinates? I'm going to multiply them by -1. And what else? Shift 5 units to the right. Okay? In that order. I've got to multiply first and then shift. Okay? Same thing on the outside. I'm going to multiply the y coordinates by -3 and add 2 in that order. Always multiply before you shift. And if it helps you to write all these points out before you go to graph, then you can do that. We're going to multiply all the x coordinates by -1, so that's going to be 8, 1, 0, -1, -8. And we're going to move them 5 to the right, which means I'm going to add 5 to each of those. Then for the y coordinates, I'm going to multiply all the y coordinates by -3. And I'm going to shift 2 units up. So I'm going to add 2 to all the y coordinates. Okay. So our points now are going to be 13, 8. 6, 5. 5, 2. 4, -1, and -3, -4. There's what the graph of that cubic root looks like. Any other questions? Yeah, John? Number 4. Number 4, this is the greatest integer function. Okay, so we got to remember that's the step function, and it helps us to remember what that looks like. And I think the best thing to do is just kind of have that picture of the parent function for greatest integers. Okay, there's 3 steps that are on the parent function. Now, based on this equation, what all are we going to do with each step? All right, 4 to the left. Multiply the y coordinates by 2. and then move down 1. Okay? Let's apply that to the entire step. Okay? So this step right here, I'm going to move get one at a time. All right, so this one I'll go 1, 2, 3, 4 to the left. Okay, what are all the y coordinates right now on that step? 0. So if I multiply 2 times 0, I get 0, and then I'm going to move 1 unit down. So that's where that step ends up. Okay? Same thing with the next step. Shift it 1, 2, 3, 4 units to the left. What are the y coordinates right now? 1. If I do 2 times 1, I'm going to get 2. And then what do? Shift it 1 unit down. Next step, go 4 to the left. What are the y coordinates right now? 2. If I multiply those y coordinates by 2, I'm going to get 4. And then I'm going to shift down 1. Once you have 3 of those steps, then it's following that same pattern. So you can see each step is 1 unit long. And what's the difference between them? 2 units. So the next one will be 2 units above, then 2 more units above, 2 more units above. Same thing down here. There would be that graph.
Number 1, I'm not really seeing okay, 6 pictures there, but I've done it like I still got everything in the same place. I still got everything in the same place.
Yes, that was my Anything else on the quiz?
Oh, yeah.
All right, 6A. First off, you had to read the instructions, and if some of you didn't read it. It said, determine if the following equations represent a function. Some of you never indicated if it was a function or not. Or some of you, on one of them you indicated it was not a function, but you didn't tell me on the other 2. You had to tell me for all 3 whether it was a function or not. 6A, is it a function? Yes, because the only y is right here, and it does not have absolute values, and it does not have an even exponent. Okay? So it is a function. I could have asked you even more, if it is a function, is it a one-to-one function? And what would you have told me for this one? It's not one-to-one because the x has absolute values. Okay? So if it is a function, then you apply the same rules to x to determine if it's one-to-one or not. So A is a function, B is not a function because the y is squared, and then C is a function because what's the rule on y? Even exponent or absolute value. And that y has an odd exponent. So it would be a function. Okay? And then, once you identify that it's a function or not, you're going to tell me the x and y intercepts. And so to find the x-intercepts, what do we do? Plug in 0 for y. Okay? Remember, you have to write intercepts as a point because they are a point on the graph. So you have to tell me the x and y coordinates. And for the x-intercept, the y coordinate is 0. So I'll plug in 0 for y. I'm going to get the absolute value by itself by subtracting 16 over. and then dividing by 4. And you should not have done anything else. Because when does an absolute value equal a negative number? Never. So there are no x-intercepts. But even if you did, and you got 5 and negative 3, if you were to plug 5 in, you would say 5 minus 1 is 4. The absolute value of 4 is not equal to negative 4, so that's not right. The same thing happens with negative 3. So there are no x-intercepts because it's not possible for an absolute value to equal a negative number. And then for the y-intercept, usually much easier to find the y-intercept. We just plug in 0 for x. And in this case, when I plug in 0, 0 minus 1 is negative 1. The absolute value is 1. Times 4 plus 16 is 20. And so 20 over 8. And I don't even care if you reduce fractions anymore. You can leave it as 20 over 8. Or you could write it as 5 halves. That's fine.
Wait, so I forgot that. Did you see that control that?
Yeah. Sorry. I don't know why. All right. Anything else on your quiz? Yeah.
4, all of 4,
All right. Remember, finding domain is a really important concept. You're going to have several questions about domain on your test tomorrow. So for 4A, what are the 2 issues relevant to domain? What are the 2 issues with domain? Denominators and even roots, right? Denominators and even roots. In this case, we have a denominator, and what specifically do we have to worry about with denominators? What makes the denominator equal to 0, right? Because what we're looking for with domain is what is going to give us a defined value for y. Any x that gives us a defined value for y. And I have to restrict anything that does not give me a defined value for y. So in this case, I want to find any x's that are going to make this denominator equal to 0 because I got to restrict those. Those x's would cause me to get something that's undefined because I would get a 0 in the denominator. Right? This proves to be factorable, I believe, as x minus 3 and 2x plus 3.
I got X minus 3.
Yeah. X minus 3 and 2x plus 3.
Yeah.
So if x is 3 or negative 3 halves, then I'm going to get a 0 in the denominator. So actually what I have to do is restrict those. X cannot be those 2 values. So when I go to write the domain, I'm going to start at negative infinity. I'm going to go to negative 3 halves. But x cannot be that value. So what do I do? Parentheses. Then I'll go from negative 3 halves to 3. But again, x cannot be 3. And then I'll go from 3 to positive infinity. Why am I not testing the intervals in this problem? Because there's no inequality, right? No inequality. This is just a case where you got to find the specific values that would give me a 0 in the denominator, and then put the parentheses around it. Right? Whereas in part C, I give you the function f of x equals the square root of 25 minus 4x squared. That's a square root, and what's inside square roots has to be positive or 0. Now I am going to factor again. But this time, I do test the intervals because it's an inequality. And what numbers would I place on the number line? Negative 5 halves and positive 5 halves. with closed circles because I can be equal to 0. And when I test the intervals by picking numbers in each of those intervals, it turns out that in between these two values, I choose 0, I get a positive times a positive. And since I want positive values, this interval works. In the other intervals, I end up with negative values, which is not what I want. So my domain for part C is bracket negative 5/2 to positive 5/2. And that's the only interval where that works. And then for part B, I have a square root in a denominator. So what does that mean about the x plus 3? Just greater than 0. Okay? Just greater than 0. Because it cannot equal 0, otherwise I'll have a 0 in the denominator. That's linear. That's just x is greater than negative 3. So negative 3 a positive thing would be there.
Number 5B.
5B. Alright, this one asks you to test for symmetry, and then to identify whether it's even or odd based on its symmetry. Alright, how do I test for x-axis symmetry? Plug in negative for y. So I would have 6x to the 5th minus 8 times a negative y equals 5 times a negative y plus 4x cubed. Is that the exact same equation that I started with? Nope. So we do not have x-axis symmetry. Test for y-axis symmetry, what do? Plug in negative x. Is that the same exact equation I'm going to start with? No, why not? Is that negative going to stick around? Yeah, with the odd exponents it will. And so that would be negative 6x to the 5th minus 8y equals 5y minus 4x cubed. That's not the exact same equation we started with. Okay, to test for origin symmetry, we plug in negatives for both. And what I'll have is negative 6x to the 5th plus 8y equals negative 5y minus 4x cubed. Okay, because all the negatives stayed. None of them got canceled out. Is that the exact same equation I start with? No. But if I multiply both sides by negative 1, then it's an equal sign, so I can. 6 is positive, the 8 is negative, the 5 is positive, the 4 is positive. Is that the same thing we started with?
Yes.
Yes. So it has origin symmetry, which makes it an odd function.
So you can
On both sides, right?
Okay, I have a question about 4B. You said you didn't put that like little line under the inequality. But couldn't it be 0, 2 because it's
It's in a denominator. So if it equals 0, then you have a 0 in the denominator.
you can't put a bracket.
All right. Like I said, I'll put the answers to the quiz up on the website. So if there were any of the other ones that we didn't go over that you need to look over a little bit more, then you can do that. Take out your, which homework do you want to go over? 2 nights ago or last night's? 2 nights ago. That was from the textbook. What was the page numbers for that? All right. What questions might you have? 89. All right. 89 says minimizing the marginal cost. And when you take economics, you'll learn a whole lot about the marginal cost. We'll even talk a little bit about it in calculus. It just says the marginal cost of a product can be thought of as the cost of producing one additional unit of output. Okay, so the marginal cost is how much does it cost to produce the next item. Okay, I've already bought all my supplies. I bought the facility where I'm putting all these supplies together. I've got people there to work. So the marginal cost is how much is it going to cost to produce the next item. So it might mean that I need to buy a little bit more supplies, or maybe I've got to pay somebody a little bit longer to create the next item. How much is that going to cost to produce the next item? That's the marginal cost. For example, if the marginal cost of producing the 50th product is $6.20, it costs $6.20 to increase production from 49 to 50 units of output. Okay, just giving you an example of what I just said. If it costs this much to produce the next one, then that's called the marginal cost. Suppose the marginal cost C is given by this function. C of x equals x squared minus 140x plus 7,400. So that's the marginal cost in dollars, and it's to produce X thousand MP3 players. So A, how many MP3 players should be produced to minimize the marginal cost? Well, where does a maximum or a minimum occur? At a vertex. This particular parabola opens upward, so the vertex is going to be at the bottom, and that's going to be where that minimum is located. So we'll do x equals negative b over 2a, and what do you get? 70. But remember, you read the problem, and the problem indicated that it's in x thousands of MP3 players. So when the question asks how many MP3 players should be produced to minimize the marginal cost, you're going to tell me 70,000 MP3 players, because X is measured in thousands. Okay? That will minimize the marginal cost. And then, what is the minimum marginal cost? So then what you're going to do is replace X with 70 and figure that out.
So it's the same as on this pack.
Yep, same thing. It's just this case the parabola opens upwards. Any other questions on homework from 2 nights ago on page 156 to 158? Remember, I think in your textbook all the odd answers are in the back of the book. So I like to give you odd problems so that you have those answers to check against, so make use of that. But you're also welcome. My textbook up here has all the answers in for even and odd here, so you're always welcome to come look at that and check your work. So like in Hornet Block, if you're doing a problem and you want to come by and check that out, or before school if you want to come by and check it out, you're welcome to do that. I don't care. You know, you're not going to get answers. You're not going to get credit for just answers on your homework, so it's not like the answers are a big secret. So feel free to use that. 73? We haven't done one quite like that before. 73 says the graph of the function, it just gives you the standard form for a parabola. Ax squared plus bx plus c. The graph of this function has a vertex at 0, 2, and it also passes through the point 1, 8. Well, the vertex is kind of key here, because how do you go about finding the vertex from standard form? Yeah, you do x equals negative b over 2a. Well, if I know what the vertex is, then what can I take away from this? I do have h and k. What else do I know from that vertex? This x is what? 0. Because remember, that gives me the axis of symmetry and it gives me the x-coordinate of the vertex. The x-coordinate of the vertex is 0. When does a fraction equal 0? When the numerator is 0. So now I know b is 0. Right? Because for that fraction to equal 0, b has to be 0. So what I know now is f of x equals ax squared plus c. Because that bx term is canceled out. B was 0. Now what can I do? Well, these points are on that graph, right? So when I plug 0 in for x, I should get 2 for y. And when I plug 1 in for x, I should get 8 for y. So if I plug 0 in for x, 8 times 0 squared plus c equals 2. What does that tell me? C is 2. And then I also know that when x is 1, and now I know that c is 2, y is 8. So that means that 8 equals 1 squared is just 1. So what's 8? 6. There's A, B, and C. So it's just a matter of taking those points and plugging them in to figure out the values of A, B, and C. Any other questions on this homework? All right, then let's go to last night's homework. Questions? No.
Oh, wait, I have a question on number 7 from page 1.
165. Number 7. Okay. Is there a particular part that you need to go over?
I just got a little explanation.
All right. So it says that David has 400 yards of fencing in which is to enclose a rectangular field. So here's this rectangular field. And there's 400 feet of fencing, so we know that 400 equals 2L plus 2W. And what we're trying to do in part A is to express the area as a function of the width. So what I know is that area equals length times width. But when you hear that term, express the area as a function of the width, that means that the only variables that they want are A and W. So I got to get rid of L somehow. And the way I can do that is by coming back over here and figuring out what L is equal to. L is equal to 200 minus W. So I'll plug that in over here. Replace L with 200 minus W. And then distribute that W in. There's my function that has the area in terms of the width. Those are the only two variables that are there. And then for what value of W is the area the largest? So maximize the area, which we're going to do by saying negative B over 2A. And that ends up being 100. So when the width is 100 feet, we have the biggest area. And then what's the maximum area? We'll just plug 100 in to this area formula, and you'll get your answer, which is 10,000 square yards.
Number 19 on the same page.
19. Chemistry. Yeah. A self-catalytic chemical reaction results in the formation of a compound that causes the formation ratio to increase. I'm sure if you're in AP Chemistry. That all makes perfect sense to me. But it gives us the reaction rate B. Where K is a positive constant, A is the initial amount of the compound, so it's a constant as well, and X is the variable amount of the compound. That's a variable because it's changing throughout this reaction. And I want to know for what value of X is the reaction rate a maximum. We're calculating a maximum which occurs at a vertex, so what kind of function do we need? Quadratic? Right? The only function you know how to find the vertex of is a quadratic one. Well, luckily, we have a quadratic function, even if it doesn't look like it. When I distribute that in, that's kx times negative x, and then plus kx times a. So for what value of x am I going to have a maximum? Well, the maximum still occurs at negative b over 2a. It's just that in this problem, what's b? AK. And what's a? Negative k. So that's negative AK over negative 2K. K's cancel, negatives cancel when X equals A over 2. And that'll be the value of X. In fact, what that really is saying is if A is the initial compound, it's going to be at its maximum rate of reaction when you've gotten rid of half of the original amount. Makes sense if you're taking chemistry. Anything else on this homework? All right, then let's go to last night's homework. Anything on that you want to go over? Which one, Lee? Number 5? What is that the equation of? It's a circle, okay? It's in our form of x minus h squared plus y minus k squared equals r squared. So from there, we're going to identify the center and the radius. What's the radius? 6. What's the center of the circle? 0, 3. Okay? It's x minus h. So that's like x minus 0. And then y minus k. So 0, 3, and then from that center, we go 6 in each direction. And then you do your best to draw a circle. Recognizing we can't all be a Glover.
Oh, color circles are awful. Look at those.
She's not that
You need some lessons.
That was like my 5th try too.
Is Fish Glover even your father? Any other questions? Number 8. Alright, number 8 is a piecewise function with 2 different pieces. Luckily, the pieces are really not going to be overly difficult to graph themselves because the first one is an absolute value function, and all we're doing to that absolute value function is what? Going 3 to the left. So if you just know the points that are on the absolute value function, you're just moving them all 3 units to the left. So that'd be negative 2, 2, go 3 to the left, negative 1, 1, 3 to the left, 0, 0, 3 to the left, 1, 1, 3 to the left, 2, 2, 3 to the left. And here would be this absolute value function. But where are we cutting it? At negative 2, which is right here. And which part are we keeping? Left. Open or close circle. So there's that piece. Okay. And then the second piece is a parabola, but all we're doing to that parabola is shifting it 1 to the right. Okay, so our points are negative 2, 4, go 1 to the right. Negative 1, 1, go 1 to the right. 0, 0, go 1 to the right. 1, 1, 1 to the right. 2, 4, 1 to the right. Here would be this parabola. Where are we cutting this one? At 0, which is right here. And which part are we keeping? Everything to the right. Open or close circle? Close. Okay. So these piecewise functions don't have to start and stop at the same x coordinate. There can be a gap between them. And that's what happens here. Is this continuous? No, it's not. What would its domain be? Negative infinity to negative 2, parentheses, union, bracket, 0 to positive infinity would be its domain. Okay. Its range would be from 0 to positive infinity.
Can you go for number 9?
Yeah.
Number 9.
And what was the answer to number 11? Like, just, was it only 1 or? Number 11. Like, which ones are continuous?
Oh, to number 11, which ones were continuous? I don't think. What dog it?
I
only got number
7 is continuous. Obviously, 8 is not. Number 9. Nine is continuous. 10 is not continuous. Wait a minute. Good. Yeah, 10 is continuous. I'm sorry. 10 is continuous. So 7, 9, and 10 are continuous. Ah, you're right. 9 is not continuous at 4. Because at 4, neither of those are equal to. They're both open circles. So yes, 9 would not be continuous. So it is just 7 and 10.
57 and 10.
Use 9 and 9 first. 7, 9.
All right, I'll do 9.
I'll stay
Just put it on my desk. All right, number 9. Let's do this quick because we're running out of time. The first one is a cubic root function. So I'm not going to write everything up, so you can kind of just follow along. Looking at that cubic root function, I'm going to multiply all the x coordinates by 1/4. Then I'm going to multiply the y coordinates by -1 and move the graph 3 units up. So with it being a cubic root function, I have the point -8, -2. Multiply the y coordinates by 4. Multiply the y coordinates, the x coordinates by 4. Multiply the y coordinates by -1, and then move it up 3 units. Then I have -1, -1 as a point on the apparent function. 0, 0 as a point on the parent function. 1, 1 as a point on the parent function. And A2 is a point of the parent function. And so here's what, that doesn't look right.
No.
That point's right here. So here is this cubic function, except I'm only going to keep the part where x is less than 2. So it looks like this. Right? And the next part is a linear function. That should be pretty easy. It's got a y-intercept of 5 and a slope of -2. So I'll put my y-intercept at 5. And then I'll go slope of -2 goes down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. So on. So here's this entire line. But what part of the line do I want to keep? Between 2 and 4. So anything that's not between where x is 2 and where x is 4 goes away. And am I going to do an open circle or a closed circle? All right, this one's closed at 2. And then at 4, it's open, right? Then the last piece is a quadratic. What do I have to do? What do you got to do with this quadratic? How do you graph quadratics? Come on, folks. Right, you got to find the vertex. You got to do negative e over 2a. Then that gives you hk. And help me out a little bit. What do you get?
Y equals 1 4 x minus 6 minus 4.
X.
Minus 6 squared minus 4.
Okay. So we're going to shift 6 units to the right. We're going to multiply the y coordinates by 4, and then shift 4 units down. So the point that's at -2, 4, I'm going to go 6 units to the right. I'm going to multiply the y coordinate by 4, and then shift 4 units down. So it's going to be that point. And then, I'll do that for every single point. So 0, 0, go. So this parabola looks something like this. And at 4, it's still an open circle because neither of those were closed in. Neither of those were connected. Okay? And that is not continuous because of that open circle. All right, the answers to the study guide are up on the website. The answers to the lesson quiz will be up on the website momentarily. You got plenty to study, especially your class starters. If you want to look over those. Otherwise, there you go. Be ready.